for the introduction. Yeah, so I was given a brief to talk about welfare and also technologies in one presentation. So I'm hoping that I can give a little bit of an overview of some of the things that might be going on. I'm aware there's a wide range of people here and their experiences. So yeah, apologies if some bits you know about already. So my background, I should probably say, as well as lecturing at the University of Reading, I've also involved in a number of trials and research projects which have involved wearable technology on cattle predominantly. So this slightly Heath Robinson cow on the title screen is wearing a local positioning sensor and accelerometer in there as well. And this was in an early stage kind of plastic box with gaffer tape approach to technology. I was kind of asked to give a bit of an overview of where we're at. Now, this is a very slightly out of date overview, but I thought it was a really useful place to start. So this is a paper by someone who was doing a PhD at Reading with us, at Juliet Schillings. And what she did was she reviewed the available precision livestock farming technologies, and she's done it under the framework of the 5 domains welfare framework. So I'll come to that a little bit in a minute. And what she did was found a whole number of different technologies, and she's classified in terms of where they are in terms of readiness on the market as well. So this is a bit of an overview of the commercialized technologies that were out there. And what we can kind of see is that with the cattle, we've had quite a long sort of history of accelerometers type technologies, so both neck, leg, and now ear mounted, and also boluses with accelerometers in there. So we're quite advanced in terms of individual animal activity monitoring, and these have been focused around often commercially important characteristics like rumination, feeding, and things that are related to the health and the well-being of the animal, or commercially important things like getting dairy cattle pregnant and things like that. So we're quite good on individual animal sensors for cattle. On the pigs and poultry side, there's been work on electronic feeding systems and monitoring water. And what the pig and poultry guys have been much better at doing than probably the cattle and sheep side of things is environmental monitoring. Their housing is a lot more controlled than the cattle side, so they're very much more advanced in environmental monitoring and control, and building temperatures, building ventilation, and all those sorts of things. And we mustn't forget the fish as well. So there is work that's been done in terms of hydroacoustic technologies and camera technologies to look at feed consumption, appetite, health of animals, those sorts of things. So we've got a range of technologies available. Oops, I missed one there. And what Juliet Schillings did was look at them in terms of the 5 domains model. Now, I don't know where everybody is in terms of their welfare understanding. So, a very quick overview. Most of you, I hope, will have heard of the 5 freedoms system and the framework that we've used quite widely now. Across all different species, companion, zoo, everywhere, and that framework came out of the Bramble report, and from that, basically the outcome of the report, was that animals should be able to move around, turn around, and groom itself and stretch its limbs. So those very basic needs developed into the 5 freedoms. But the 5 freedoms have got some sort of they're very simple, very easy to use, but they have a few kind of downsides to them. One, they were largely about understanding the suitability of a production system rather than as an assessment for individual animals. And what Mella has done is develop this framework called the 5 domains framework, which takes it's very similar to the 5 freedoms in terms of these physical domains, the first 4 domains. You can see a lot of synergies there, but they've really focused in on the extended version on being able to kind of pull apart both the negative, eliminating the negative experiences for the animals, but also taking into this world of considering the positive experiences for the animals. And they've also looked at how the physical domains map onto and interact with the mental domain, the actual mental experiences of the animal. So I'm not going to go through this in great detail, but just to show you how complex it is if you've not come across it. This is the health domain, and here what you've got is on the red text side, you've got the negative conditions. So things like an injury or a mutilation, and then the experience from that would be the pain, the nausea, the malaise, things like that. And then on the other side, we've got the positive conditions. So if we don't have injuries, we've got this comfort, good health function. So it's quite a comprehensive framework when you look at the whole thing. And that then maps into these behavioral interactions, which were the 4th domain. So I'm not going to let you look at that because it's so teeny tiny, but we shrink it down and look at just 2 parts of that. We've got the consideration of interactions with the environment in terms of behavior. We've got interactions with other animals. And the one that was at the bottom was interaction with humans as well. So we've got all of these things to consider when we're thinking about welfare of these animals. And what the 5 domains is really trying to get to is they are trying to make us think about going beyond a life worth living and into this concept of a good life. And a good life is where the positive experiences that an animal gets outweigh the negative ones. So it's not saying that that there will never be any negative experiences for any animals, but what we want to do is try and make their positive experiences as good as we can and as many as we can. And this could be just as simple as if we're going to disbud an animal, providing long-acting pain relief afterwards, so that we get them back into the sort of improve their welfare following it. You might even think about the environment that the animal is in. And some work that we've been doing with a PhD student recently has shown that the responses of calves varies depending on whether they're in an enriched environment or not. So the disbudded calves that were in a pen with different types of enrichment got up and played much more quickly than their counterparts that were in an environment without. So our providing more enriched environments not only gives them a positive experience at different times, but it can also help to negate some of the negative experiences that they might have as well. So back to the review by Schilling. So this is the research papers that she looked at. So the first slide was purely the commercialized systems, and this is the research papers. So we can see here where the research has been happening in terms of positive welfare. Sorry, in terms of precision livestock farming. We've got a lot of work going on with cattle and pigs and poultry, and to a lesser extent with fish and other poultry species there, and sheep and goats. And we've got a wide range of different technologies there. So you've got automatic weighing systems, things for vocalizations. We've got acoustic-based systems, visual systems, accelerometer-based systems. And but what I should probably highlight most of all is that, largely speaking, we're still in this realm of eliminating negative experiences. There's a little bit here of, in the image analysis, of play behavior and human-animal interaction, and we've got some work with social networks and local positioning. So yeah, we are really only just starting to scratch the surface of positive welfare. So I did a quick search to find out what there was going on in terms of positive welfare, and I'm not going to talk too much about this because Francoise is going to be speaking to you later. But the single paper that sort of really in their title said we've looked at technology and positive welfare was one using qualitative behavioural assessment to assess animals. So this was with dairy cattle, and it's a BSAS paper if you want to go and look for it. And this was the main one that started to actually unpick, looking at a positive a behavioural assessment that has both positive and negative valences there, and also the technology as well. So they found associations between the environment that the cows were in and between their activities, with cows considered to be happier to actually having a positive correlation with step count. So they were more active and doing more positive active behaviours. So why isn't there so much more on positive welfare? It's not the newest sort of thing out there. We've been moving towards this concept of positive welfare for a while. Well, I think it's difficult because we don't fully understand what is positive for our animals. So we need to spend more time looking at what our animals are doing, and also looking at their environment. So that this domains model here shows the importance of considering all of these things. And sometimes what we've been doing is we've been looking at the animal behavior and trying to find out answer questions, and maybe not looking at the environment at the same time, or we've been looking at their health but not their behavior. So what the domains model reminds us is that we really should be looking at the whole lot. So in this picture, this is some cows that we had on a trial wearing our sensors. And you can see they have done this bunching behavior. And we still don't really understand what's going on with that. We know that the environment is not totally the same for all of the cows, because there are fans in the building. And there's water troughs in the middle of the building there. We don't know if it's to do with the water troughs and the fans that they've done this behaviour, or is it to do with avoiding the sunlight? We don't really know. But if we think about the domains model, what we do know is that there are impacts on their nutrition, because they've changed when they're eating and how much they're eating. They might be eating more at night. There are definitely changes to their health. Because we've got panting behavior happening associated with the temperatures in the barn and the humidity where all the animals have joined together. So we need to start looking at this whole thing. But when we did this study, we purely put some collars on some cows to look at their behavior. We weren't thinking about heat stress. It wasn't until we were in there in the summer that we started to see these different behaviors that they were performing. So the outcomes of that is, what we found is that the cows have a very, very sort of clear picture when they a clear temperature, that they start to change their behavior. Yeah, so these are some bunching metrics that we've produced. So this was the range size of the animal, so the full range of the core range, so how much of the barn they were using, and also the distance between all the cows and distance between the nearest neighbours. And all of those give this pattern of, they get to around 20 degrees and then these metrics start to shrink, so they start to get closer together. But still, we don't have the answers as to why exactly that was happening. And it didn't matter whether we picked an arbitrary temperature or whether we asked the computer to create an algorithm with a breakpoint and the computer chose it. It was all very similar. So what do we need to do? Well, we need to find out whether our buildings have really can facilitate positive welfare. Do they provide the cows with the opportunities to choose and put themselves in a comfortable position to eliminate panting behavior, to be able to have enough to drink, to moderate your temperature, all these sorts of things. So what we're really starting to think about now is deploying multiple sensor technologies within the same building. We hypothesize that the building environment is not homogeneous, and the cows are making some decisions, but we need to understand what's going on, and to try and work out what these decisions might be. So for our current study, we've got everything from fan sensors to know what the activity of the fans. We've got water temperature. We've got environmental air quality, CO2, ammonia, and temperature network around the barn, as well as the individual animal activity, position, and temperature. And hopefully with this, we can start to answer some of these questions. And I'm just going to skip through the next slide and say thank you very much, because I think I'm a bit over time.
Fantastic, Zoe. Thank you so much. What a brilliant scene set. And I've got a million questions that I've just written down, but I'm going to give the audience an opportunity to put some questions in the chat for Zoe. So thank you so much. And we'll see you a little bit later on with a Q&A session. So in the meantime, now can I invite our next speaker, Esther Harper, who is Senior Portfolio Manager at BBSRC, and she will explain what BBSRC is and why it's so important in this ecosystem. Remember, introduce yourself, put your question in the chat, and also I forgot to say a warm welcome to colleagues from Suffolk, Rural College Suffolk, where this is being streamed to. So you're all very welcome. Hope you're taking loads of notes and hope this all appears in some assignments. Esther, I see you've shared your screen. Over to you. I think you're on mute, Esther.
Can everyone see my screen okay?
Yep, that's fine.
Yes.
Thank you.
Well, hi, thanks to Belinda and colleagues for asking me to speak at this session today. I'm Esther Harper. I'm a Senior Portfolio Manager in the Business Interaction Unit at the Biotechnology and Biological Sciences Research Council, also known as BBSRC, because it's a bit of a mouthful. And I work across the whole of our farmed animals portfolio, which includes all of your kind of traditional land-based livestock, but also includes aquaculture and insect farming and apiculture. So it's quite a broad portfolio. I wanted to talk to you today a little bit about how the Business Interaction Unit works together with academic researchers and industry, and also highlight a few networks to you that might be of interest in the context of this call today, and also highlight some funding opportunities that are live at the moment that might also be of interest to you. So, firstly, you may have already heard of BBSRC, and so we are an independent organisation. We're part of UK Research and Innovation, and we receive our money directly from the Department for Science, Industry and Technology, and we work closely with business in my team, so that we can bring together businesses with our leading bioscience, biotechnology research facilities and universities across the country, and we also work together with businesses and researchers to shape strategic funding programs through key areas that are highlighted to us through that engagement. And we also support businesses to support the future generation of researchers and to meet the key skills needs that they have within their sectors. And we also work closely with colleagues at Innovate UK to accelerate and maximise the impact of bioscience through business-led innovation. So our team works broadly across two different areas. The first part of our portfolio of investments is the business partnering portfolio. So this is run through our responsive mode programs, and it provides an opportunity for businesses of all sizes to collaborate on projects led by universities, and those projects can be from a varying length of time. And these funding opportunities, which you see at the bottom, are so IPA, Industrial Partnership Awards, and Link Awards are open all the time. And you may have also heard of our Prosperity Partnership Programme. These are large investments that focus on large-scale strategic challenges, and they are developed in collaboration between industry and academia. So, looking more closely at the IPA and Link Awards, so they support short and medium-term partnerships focused on a specific research project. So the IPAs are more closely led by industry, by academia, sorry. And whereas the Link Awards are more applied research with significant industry involvement. And as you can see, that's partly reflected in terms of the contribution from the industry partner. So IPA awards require a 10% cash investment from the industry partner, whereas for the BBSRC Link programme, we would expect a 50% cash and or in-kind contribution from the industry partner. So a relatively new programme for BBSRC is the Prosperity Partnership Scheme, which supports long-term business-led strategic research partnerships. We also have programmes to support the community and capacity building, such as our STFC Access to Facilities core, and we also provide business interaction vouchers for bioimaging and networks, such as, for example, the NIBS programme, so networks in industrial biotechnology and bioenergy. The other strand of our portfolio is the Strategic Innovation Programme. So these are programmes where we work closely with our strategic partners to develop these competitive, so pre-competitive R&D programmes. Quite a few of them include co-investment with other UKRI research councils, as well as UK government, such as DEFRA. They're designed around key opportunities for industry or potential barriers to innovation. I'm going to talk you through some of those programmes that are ongoing at the moment that relate to the livestock farming portfolio, which I work on. So I'm definitely have seen a few familiar names in the chat already. So a few of you, I believe, are all actually involved in the Endemic Livestock Diseases Initiative. So this was developed really closely with collaboration with industry and academia to provide key research funding for these strategic challenges around endemic diseases within UK livestock, and specifically focusing on delivering on-farm solutions. So in terms of this programme, a lot of what we focused on was connecting farmers to the research and translation activities. And we worked closely with colleagues in AHDB to run the initial seed funding awards, which provided some very small grants at sort of 3 to 6 months to start to bring partnerships together, and then developed those further into longer grants. And currently we have the second phase of this initiative is ongoing, and it was again developed closely with colleagues from DEFRA and Scottish Government, and it relates directly to DEFRA's Animal Health and Welfare Pathway. Sorry, I've pushed the wrong button on my screen. So another programme that we developed closely with industry was the Sustainable Aquaculture Partnerships for Innovation programme, which is up and running now. And so this is a programme that was developed closely with the UK aquaculture industry and academic expertise within that space, because we recognised so there are key challenges around environmental sustainability for the UK aquaculture sector, and bringing together industry and academia to solve those challenges was seen as one of the key opportunities for success in this area. And the projects that we funded cover a huge range of areas, from environmental sustainability and climate change, including water quality, biodiversity and climate adaptation of farm species, gene editing and selective breeding, species diversification within aquaculture in the UK, production and handling technologies, including remote monitoring and sensing, and also improving the health of farmed aquatic animals in a changing climate, nutrition and feeding, which includes reducing the reliance on fish meal and fish oil. And lastly, I wanted to touch on the Technologies for Animal Welfare Seeding Awards, which have just been awarded a couple of months ago. So the aim of this seed funding award is to bring together businesses and or third sector organisations with academic researchers to support the development of animal welfare technologies that are of the direct relevance to industry, policymakers and end users, and other key stakeholders within that space. And so this seed funding award mechanism allows us at BBSRC to quickly invest in building capabilities in eligible research organisations that have a strong track record of successfully using BBSRC funds in a specific area. And these awards provide flexible funding, which underpins the formation of new partnerships to address sector challenges around developing these technologies for animal welfare. And Zoe, you spoke earlier. I was going to say, do let your colleague Juliet know that the paper that you mentioned in your presentation, we quoted that as evidence for the development in this funding opportunity. So thanks for that. And there will be numerous activities happening around this Technologies for Animal Welfare Seeding Awards, which I'm going to touch on in a moment. So alongside these, BBSRC also funds a range of networks and research clubs. And the first one I wanted to point you towards is the AI Bio Network. So this is supported by BBSRC funding, but actively looks to engage across remit boundaries, which perhaps you might think of traditionally as being more engineering and physical sciences. There was a kick-off event in early January last year, and the network is really keen for people to get in touch. They have sort of primary aims, which I've set out here in the slide. They'd be really interested to engage with anyone who's working on the kind of agri tech side of things. So I've got the email there and the link in the slides, and I'm sure we can share these around with you all afterwards. So yeah, if that sounds of interest to you, do reach out to them. And the other network I wanted to point you towards, which I think quite a few of you are probably already aware of, is the Animal Welfare Research Network, which aims to bring together the animal welfare research community, researchers and stakeholders with a professional interest in animal welfare issues. And they have an upcoming workshop at Harper in February, so quite soon. I wanted to plug it here because I expect quite a few of you might be at Dairy Tech and can tack on an extra day. So this is one of the workshops that is being funded through the Technologies for Animal Welfare Seed Funding Award. And again, do reach out to the Animal Welfare Research Network if you're not already in touch with them. I wanted to very quickly also whiz through a couple of funding opportunities which are open at the moment.
Got 1 minute, Esther. 1 minute, please.
Okay, so very quickly, BBSRC follow-on fund. If you've already received BBSRC funding, please do take a look at that. It might be a way to support you to deliver outcomes such as product spin-outs and licensable IP. And I also wanted to mention the BBSRC iCure program, which again is focused very much on sort of reaching innovation, and there are different programs which you can explore through the BBSRC iCure pathway depending on where you're looking at, and the Engage program is open now, so do have a look at the iCure program website. Right, and I hope that means that I have whizzed through it just about in time.
Brilliant. Thank you so much, Esther. That's a really helpful overview. And clearly, you know, while it is a tight funding landscape, there is money available for both academic and industry to do their thing and do it together. So that's really positive. So we'll share the details of this if anybody didn't manage to capture them. But thank you so much, Esther. And we very much enjoy working with you and colleagues at BBSRC. You're great enablers for all of this technology. So thank you. Okay, so shall we move on to the codes? So if I could invite you, Esther, to turn your camera off and to welcome Phil Cullinhan, who is Business Development Manager at Nantwich Farm Vets. Now, Phil, I think we met through a collaboration that you're already doing with one of our members that we might hear a little bit about later. But vets are so important in this community because you work with the farm businesses that are looking at doing things well, and you're a great force multiplier for technology onto farms. So without further ado, the floor is yours.
Thanks, Belinda. Can you hear me okay?
We can, that's fine. And we can see your slides. Perfect. Thank you.
Very good. I will crack on then in the interest of time. So yeah, as Belinda said, I work at Nantwich Farm Vets. Just a little bit of background on us. We are based, as the name suggests, near Nantwich. But we do serve farms across Cheshire, Shropshire, Staffordshire and North Wales. So we do a lot of driving. Historically, we've been around for a long time, but in 2019, we set up the independent farm-only practice from a purpose-built building that we're in now. And we've grown a lot over that time. We're now up to 18 dedicated farm animal vets and 6 vet techs who are involved with a lot of our farms doing TB testing and also part of the farm team for routine on-farm tasks such as disbudding and mobility scoring. 2 of our vets have also got home office personal licenses, and I'll share details of a project that we're involved in with a couple of people who are also on this call, RoboScientific and SRUC. The vast majority of our work is dairy, so we look after around about 40,000 dairy cows, but we do cover beef, sheep, and the odd llama, alpaca, anything else you care to mention. And I suppose the majority of our work, we've got somewhere between 180 and 200 dairy farms that we are on very regularly, weekly, bi-weekly, monthly, as part of that farm and doing the herd health visits to really make sure that they're heading in the right direction. The brief that I was given for this talk is here on the screen, and the things that popped out to me really are animal welfare and monitoring animal welfare, improving husbandry, and really importantly from our point of view as vets, trying to identify problems before they arise. And so what I thought I'd do for this talk is try and frame that really in terms of some of the challenges that we see every day when we go out and are on farm or when we talk to farmers. And I don't think any of these will be kind of particularly surprising really, but probably after milk price, because everybody loves to grumble about milk price, some of the things that you'll hear about will be labour, difficult to get labour, and you could say skilled labour. I did wonder whether to say skilled labour, but I decided to just say labour there on farm, especially as you know, as farms get bigger, you need to be able to staff them, and that's where we'll come on to talk about some of the robotic stuff becoming more and more useful. Farms are obviously having to deal with it's too wet, it's too dry, it's too hot, it's too windy, it's too cold. So that climate changing side of things. And also as things progress, the customer, the dairy farm's customer, that is the milk buyer, so Tesco, Waitrose, all Arla, etc., all of those, but also the consumer. So us, basically, our expectations are changing, partly framed by the growing awareness of what's happening in the industry and technologies and people going onto farms and putting up video cameras and posting on Facebook has definitely highlighted some of those. And then I think one of the other challenges that is just worth mentioning, and you'll get a bit of an impression for it later on, is the amount of choice that's available to farmers when they're trying to work out, well, what can we do to help us? There's so much available that there's an opportunity, or there's a potential for too much choice, really. When I sat down, this is sort of my initial scribbles when I was designing this presentation, and I started thinking about, the past, the present, and the future, and I was looking at the different areas that we have on our farm, so mastitis, lameness, fertility, and young stock. And I soon realized that there was just too much to try and cram into 10 minutes, and also a lot of things that were spanning across all of those different areas. So what I've decided to do is just focus very briefly on 3 areas. The first of which is robotics. And really, you'll see that a lot of this is how do we get something on farm to do something that humans can do, but do it instead of needing a human. We've then got data collection and automation, and there's an element of that. There's an element of this technology doing stuff that we could do, but the majority of it is probably doing it far better, 24/7, more consistently than we can do. And then when you get into the automation and the analysis and the analytics side of things, that's stuff that humans can't really do, and that I think is where there's a lot of opportunity. And I'll touch very briefly on genetics, but there really isn't enough time to go into kind of the potentials for that in the future. So moving on, and I hope you can see this video working. Please do shout out if you can't. But this is probably, if I said robot milkers to most people, this is probably what they would think of. They would think of an individual stall that a cow chooses to walk into to get herself milked at a frequency that she wants to be milked. And that machine, one robot milker can look after in the region of 50 cows, and it will also, as well as doing the manual task of milking the cow, start to provide data such as cell count recording, milk liters, those types of parameters to enable the farmer to have an understanding of what's happening with that cow at that time. Something that's probably less common and less familiar is this type of robot. So this is a big 60-point rotary on one of our farms that has now employed, in the loosest sense of the word, a robot to come on and do the pre-milking teat preparation. So you can see it's just going in there, it's preparing the teats of that cow, and then a little squirt and a clean of itself before it moves in and prepares the teats of the next cow. So that's doing that for every single cow and essentially replacing a human in the parlour. And then at the other side of the parlour, we've got this robot, which is after the cows have been milked, doing the post-milking teat disinfection teat prep sealant to make sure that those cows are at less risk of getting mastitis when their teat canals are open. And if you think of this particular rotary parlour that's milking 3 times a day, roughly 5 hours per milking, that's 2 robots, each working 15 hours a day. That's about 11,000 hours a year that those 2 robots are covering. And they're doing it without holidays, without sick pay. So you can see how that's a real help labour saving on a farm. To put a value on that, if you were to be relatively conservative and say 20 quid an hour, then you're looking at over £200,000 a year that those robots are saving. A different type of robot now, this is the Lely feed kitchen that we've got on another one of our farms. This area here is the feed bunker where the farmer puts different kinds of feed materials, and there'll be some straight storage just off to the side here. And this little crane moves along once the diet's programmed to pick up the right amount of feed and put it into this Lely vector, which then trundles along on its automatic path, mixes the feed and feeds the cows. And it can do multiple groups. This is one of those ones where it can replace a human and does replace a human, but arguably somebody that's really interested in nutrition and has a big mixer wagon which can mix the feed essentially longer and better might actually do a better job than one of those. And then from the point of view of feeding calves, I'm sure many of you will be familiar. This is an automatic milk feeder which mixes and dispenses set amounts of milk to the calves, which come in with EID tags. So as well as providing them with the feed, this is also starting to capture information about how quickly the calf has drunk and how much the calf has drunk, so that that can start to act as an early warning sign for the farmer that something might not be quite right with the calf. If we think about the other end of the animals, then there's also increasing use of slurry robots on farms. These trundle up and down and keep the passageways as clean as possible. Again, coming back to the original brief and thinking about animal welfare and a disease such as digital dermatitis, if we're reducing the amount of slurry that's around and pooling, then we're keeping that infection pressure down. Something that Zoe touched on earlier was the use of robotics to manage the environment in dairy versus the way we've done it in pigs and poultry. And we are starting to see that now on some of our big farms. So this is one shed that does have humidity and temperature sensors in. It's got automatically controlled fans, as you can see there, and these kind of gale breaker sides which move up and down to limit or increase the amount of ventilation coming into this shed based on the temperature and the humidity in the shed. There's also, not on this farm, but a lot of farms are starting to use light, different wavelengths of light to mimic the kind of natural environment as much as possible to make the lives of these dairy cows as comfortable as possible. And one other thing that I guess it isn't quite a robot, but it's a piece of technology that's being employed. This is one of our largest farms. Each one of these sheds you can see houses somewhere between 400 and 500 cows. So you can imagine a challenge for the farmer that needed to implement a particular treatment on a particular animal for their welfare. Well, if you can go to your app and type in that you want to see where cow 2955 is, these GPS sensors enable you to see exactly where she is and go straight to her. So that is a huge time-saving thing for that particular farm. We've then got data collection in Vet Vision AI. I'll skip through this because I know Bobby's going to talk about that in just a second, so I won't steal his thunder. And also then we've got tools like Cattle Eye and Herd Vision that are using cameras above races to look at various points on the cow and enable automatic recording of body condition score and mobility scoring. So, really doing a job consistently that, yes, a human could do, but they're doing it much, much more in an automated fashion. This is a project that I mentioned we're involved with RoboScientific and SRUC. So this is looking at putting VOC, volatile organic compound sensing technologies on calf feeders to try and identify the specific breath fingerprint of an individual animal to differentiate between healthy and diseased. So this kit is being installed on 3 of our farms this week. So really looking forward to seeing how that project goes. And we've also, on 2 other farms this week, we've got the young stock application of SenseHub being installed to enable the farmers to get earlier detection of the way their calves are feeding, moving, etc., so that we can get a much earlier handle on disease. And that's one part of the whole SenseHub ecosystem that enables farmers to really delve into data around their cattle. Very briefly on genetic advancement, there's been lots of opportunities to look at production traits and type traits for years, and more recently health, welfare and management traits. We've seen exponential growth in the use of heifer genomic testing in recent years, which is enabling us to use genomic indexes such as the PLI index to really advance our understanding and ability to manage the breeding side of things for improving welfare. And who knows in the future what traits will be available to us to help again continue to build positively on the dairy industry. But I thought I would just also share with you as kind of us, the farm vets sitting in the middle on all these farms where this data is coming in thick and fast. We really have challenges from our point of view in terms of integrating all of that together and making sure that we're supporting the farmer to get the most of all of that. And that is where a couple of our vets have really expanded their skill set in terms of data analytics and built dashboards to help our farmers bring all of that together and actually provide them some valuable insights from all of the different systems so that we can help them to manage their herds. So really, I suppose, just to wrap it up, all of this technology should enable more, excuse the bad pun, but more time, more insights, more proactivity, and a more holistic approach, ultimately to deliver more, hopefully, more progress and better animal welfare. There is a bit of a watch out, I guess. All of that can easily lead to paralysis by analysis, to not having it all connect together. And if the robot goes wrong, then there's a gap between when it went wrong and when you've realized it's gone wrong and when you've fixed it. So there's the potential for those adverse outcomes to start happening. Also, will we start seeing those milk buyers at some point starting to restrict things and say you can only breed this type of cow or that type of cow? So really, just to end there, and on a slightly humorous note, I guess, when we spoke to one of our farmers about technology on farm, he said, well, don't forget the most important bit of technology on the farm, the kettle. So, you know, from the sublime to the ridiculous, I guess. Belinda, that's me, all done. And if anybody does want to get in touch, I would, yeah, I'd love to hear from you. Thank you very much.
Brilliant, Phil. Thank you so much. Yeah, kettle, a Swiss Army knife, and a bit of baling string. Who needs all this other technology, right?
Exactly.
Really helpful. And I think I'm particularly interested to find out more about the role as a data sort of integrator as well, because we hear this all over, that the farmers are drowning in data. So maybe we can pick that up later.
Yeah, absolutely.
Phil, thank you so much. We'll see you a bit later. And now it's my pleasure to welcome Francoise Wemelsfelder. Sorry, Francoise, I thought I wouldn't fall over that, but I did. Francoise Wemelsfelder from SRUC, who is going to be talking about the QBA app that I think we heard from Zoe mentioned, making time to monitor how animals feel. Zoe, the floor is yours. Over to you.
Can you hear me, and can you see the full screen?
Yes, both. Yes. All good, thank you.
Great. Well, I need to minimize that. Well, thank you, Belinda. Thank you so much for the invitation to speak at this really interesting workshop. And, it's not moving forward. Gosh, okay, I'll try and do it this way. Hopefully that works. Otherwise, I'll have to do it in sort of, you know, not full screen mode. Anyway, I'll be talking to you about qualitative behavior assessment and the app we created to support this method. And it's a method specifically developed, as Zoe mentioned, for assessing emotional well-being in farm animals and other animals. And the background to this work has been that animals are now, as I'm sure you are aware, increasingly acknowledged as sentient beings, and that they can think and feel. And there is a growing effort to bring these insights into animal welfare management standards. And so that was the purpose of the QBA app, to apply this approach to on-farm animal welfare management. And so briefly to summarize what QBA is, it is a method focusing on the whole dynamic animal, how animals are moving. Because at this level, we can see an emotionally expressive body language. Yes, we see physical behavior, we see animals sitting, walking, running, but we also see that they can do so in different ways. And we can ask, how are the animals sitting or walking or running? In a way that's relaxed and tense, curious and withdrawn, or playful and lethargic. So we can observe many different subtle expressive qualities of movement. And as Zoe mentioned, there's been a wonderful range of research applying this idea of QBA to animal welfare research. But in this talk, I want to focus on another very important aspect, and that is its common sense nature. The fact that when you work and live with animals, as farmers do, day in, day out, that you naturally develop this skill of reading your animal's body language. You could say it's a form of traditional stockmanship. Are animals well? Are they not well? You know, farmers will say, yeah, I can see something's not right. And so the goal of the QBA app really has been to support this skill in on-farm management. And we wanted to develop a tool that was suitable for data collection, but that would also give instant feedback on farm when, say, in farm assurance, an inspector arrives and visits the farm, observes the animals. It would be very good to have instant feedback for the farmer and the inspector while they're there. And we were very fortunate that at this same time, we were approached by Waitrose, who were interested to pioneer the inclusion of emotional well-being in their supply chain animal welfare standards. And so we agreed to collaborate in trialing this new app. And from the start, we took a participative approach. Waitrose formed focus groups for each of their supply chains, consisting of veterinarians, farmers, and farm managers. And one of their first tasks was to select a list of about 16 to 20 QBA descriptors for scoring, that they could select terms that really they were comfortable with, that they knew were useful, that they were already using, as long as these terms were balanced for positive and negative mood and for high and low energy. So you can see some examples in this chart here. But actually going through this work of selecting terms created a really great sense of engagement and ownership in the focus groups. And so here we see what it looks like when you download the app on your mobile phone. And what users do, they can create as many projects as they want. They then insert farms or groups of animals. They insert the terms that they have selected for that project. And they can then, of course, after training an inspector or a vet or together farmer, they will observe the animals on farm, and after a period of observation, make their way through the terms and score all the terms for that farm. And they do that, as you see, the green bars on the left. So they would pull the bar from the 0 location on the left to the maximum location on the right, and there's 100 measurement points in there. So once all the terms were scored, the assessor would submit. The app would automatically analyze all those scores and then provide output, which you see on the right, in a form of a graph, where the farm that has just been assessed, the position of that farm in the larger pattern of emotional expressivity is given. You can see the blue dot is the farm that's just been assessed, and the other gray dots are other farms that have been previously assessed. So the important thing is that you get instant feedback on the position, the location of an assessed farm relative to other farms in a scheme. And you can also record other features in the app and export data at front and back, but I won't have time to go into that. A key thing to note, however, here is it's important to realize that in this outcome graph, all the farm positions are relative. All these farms that you see here, including the ones on the left side of a negative emotional expressivity, are very likely very good farms. All that the app does is the analysis looks at differences, relative differences between farms in a scheme. Because emotional experience it doesn't have an absolute numerical basis. You don't count it like you would count bricks. It is a relative comparative analysis. So the app is really, this approach is really only suitable for applying, say, within an assurance scheme or within a company or within a group of farms. And you could, for example, use a traffic light approach that you can see here. These colors are not produced by the app. I've just put them on for illustration right now. But you could ask questions like, why are the farms in the left red zone have been scored with more agitation and stress or more boredom and uneasiness than the farms on the right side? So is there perhaps a problem that we should discuss together. What's going on here? Alternatively, you could ask, well, what about the farms on the right side, the green farms? What are they doing that could benefit the farms on the left? What could the red and orange farms learn from these green farms? So, in other words, this app is to generate conversations on farm about emotional well-being between farmers, vets, inspectors. It is really to there and then to create this culture of positive welfare and emotional well-being. It is not suited for enforcement because the app doesn't make absolute welfare judgments. It's important to understand that. So finally, the essence of the app, I think, is to suggest to users, to farmers and veterinarians to make time for animals, and it gives the app presents the opportunity to make time for animals and notice what is going on for them. And the farmers in the Waitrose project, I think they valued that, and they found the information they gained from doing QBA useful. And so I have this lovely quote here that, not surprisingly, came from another Juliet Schilling's paper, a wonderful paper where she wrote about uses by farmers of different technologies. And she interviewed a Waitrose broiler farm manager about the use of the QBA app. And he said, when I was doing the assessment, I noticed that the behavior of the birds was affected by light intensity. So I got my farms to upgrade their lighting systems, and I can see a positive change in the birds' behavior already. When I read that quote, I thought, wow, that is just wonderful. That is how I think it should work. Using the app sensitizes users, the vets and the farmers and to the skill they already have. They can take time to what the animals are telling them, what they are expressing, and they can interpret that, and it motivates them to make positive changes for the animals on farm. And so, to conclude, the Waitrose trial, I think it's fair to say, was a success. The farmers did engage with the approach, the QBA approach, and yeah, found it useful and found it a positive experience overall. And they provided us with a lot of very helpful feedback on the app, and we consequently spent time revising the app and technically updating it. And so the next step for us is to now make it widely available through web-based platforms, by developing a web-based platform for licensing the app and tech support. And we're currently looking into ways of securing funding for that. And I'd like to stress that we want to keep it affordable. The app needs to be self-sustaining financially, but we don't want to make it a commercial project aimed at profit. So QBA, I think it's the way it works. It helps us ask questions about animals' lives as sentient beings. And hopefully it will encourage us, as you saw in that wonderful example of the quote I just mentioned, it should encourage those who live and work with animals to enhance the positive expressivity of the animals on farm. And just a final quick comment on automation, for example, such as artificial intelligence. As Phil's talk amply illustrated, and I'm sure what's to come as well, this can be immensely helpful and do things that are very difficult to do in terms of monitoring for that to be done by humans. But I would also like to plea that we don't delegate all the monitoring to machines. I think it is vitally important that we maintain our sentient connection with animals, and that there are also tools that support that. And so that is the primary goal of the QBA app, and I hope it finds a place in sustainable agriculture in that role. And I look forward to your questions, and I'm happy to engage if you're interested in more detail. Thank you.
Francoise, thank you. What a lovely example. We often talk about this phrase with technology about the agronomist's eye and the herdsman's heart. And I think what you've got with the app is almost a codification of the herdsman's heart. But as you say, it's not a replacement. It's a support. So thank you so much for that. What brilliant stuff, and great to hear that Waitrose are on board with that as well. Right, now I'm conscious that time is moving on and we're a little bit behind schedule, and I want to give everyone a kind of 5-minute little bio break between cattle and poultry. So if you have any questions, please could you put them in the chat, and I'm going to ask the speakers, contrary to our initial discussion, please feel free to answer the questions in the app rather than us take time as a panel in plenary. So anyone in the audience has a question for any of the speakers, please type it in the chat, and speakers, if you could please answer it, that will give us some time back. Okay, and now if I could invite Robert Hyde, who is the CTO of VetVision AI. Can we monitor livestock health and welfare 24/7? Bobby is about to tell us. Over to you, Bobby.
I'm quite concerned that I feel like I'm quite bad at my job, and I've spent most of my career trying to be really good at my job. So it takes a long time to train a veterinary surgeon. So I've had 5 years of undergraduate training. I've had years in cattle practice. I've had 3 years as a specialist training to become a European specialist. And I've had another 3 years as a PhD. And still, when I'm trying to assess animal welfare and health on cattle farms, and I'm there for about 2 hours trying to assess how comfortable those animals are 365 days a year, I feel there's something missing. Maybe there's a better way. We think about how we monitor health and welfare at the moment. When you go to the supermarket and you pick that milk off the shelf, how confident are you that milk has been produced from animals that are not only healthy or even of a reasonable welfare standard, but actually having a good life, as Zoe was pointing out early on? How confident can we be with our current standards and current methods of monitoring welfare, and how often do we do those welfare assessments? It's quite a hard job for a welfare assessor to go to a particular farm and be on a farm for a few hours and make those judgments. And there's some elements of technology we can bring in. So we can bring in sensors, as some of the earlier speakers alluded to. And I love sensors. I think they're brilliant. They've got a real place here, but they have a very, very difficult job. I'm wearing a sensor right now on my wrist. I've got a smartwatch on me that tells me how active I am and so on. But as Francoise was pointing out, it's not necessarily about just what animals are doing, but it's about how they're doing it as well. And there's only so much that a sensor strapped to every single one of these animals that we can see in the picture here can tell us about their emotional and affective states. But what if we could monitor all of those behaviors individually using computer vision AI with a single camera? We can see not only what those animals are doing, where they're doing it, but how they're doing some of those behaviors as well. And if we think how our own brains have been trained overseeing thousands and thousands of animals over time, of how these animals are interacting with their environments, we can train AI algorithms in the same way we train our own vet students and consultants and animal science students, by exposing them to thousands and thousands of videos of animals doing those behaviors, and very quickly they learn those same patterns. And as Francoise was pointing out, it's not losing that link with the farm, but it takes some of that mundane task. These algorithms can watch 24 hours a day, 365 days a year, meaning that we can actually do something with that data and start changing something about the environment. Lots of amazing technology at the moment that can monitor all kinds of outcomes. I suppose the risk is always that we just try and treat what's in front of us, and apps and AI technology that can identify disease earlier is brilliant, and that means we get to treat those animals more quickly. But if we're not stopping the root cause of why animals are becoming diseased in the first place, for example, why do they become lame, then we're always going to have new disease incidents as well. And taking some of these computer vision monitored outcomes and actually doing something with the farmer about them to change the environment and see, are the cows more comfortable? Do they lie down more? What kind of behaviors change if we give them extra cubicles, we give them extra space? Suddenly you can start to measure things that we haven't been able to measure before. So of course there has to be a commercial effect here, and if we're going to make changes to animals' environments, it's got to improve their wealth, but it also has to have production benefits. So do the old adage of happy cows produce more milk, does that really stack up? If we take a farm example, just to show a real life trial of this in action, and you can look at this pen and pick a few things out about it, but you're trying to assess really, do we think the cows are comfortable in these cubicles? And if you look at this sort of time in the day, sort of 7 o'clock in the morning when you might go and visit a farm, you might think they look reasonably comfortable at this particular time snapshot if I was to come on as the farm as a welfare assessor at this point. But of course that massively changes, and if we monitor this same shed with computer vision 24 hours a day, actually you can see that the cow comfort, the proportion of cows in cubicles lying down, is about 80% if you go at 7 in the morning, but actually if you go overnight it's down at about 40 or 50%, which means about half the cows in the cubicles where they should be lying down are just standing there very, very uncomfortably. So what if we can do something about that, and we can change things in that animal's environment to make them want to lie down a bit more, make their comfort much, much better? Of course, that means their lying times then also will go up, and these animals are now lying down much more in those cubicles than they were previously because we've been able to change things in that environment. And if we take the literature on what that should equate to, then about an hour of lying actually equates to something like 1 litre to 1.5 litres more milk production. Now, this is a bit of a trial by convenience, but we had a very similar occurrence at our own university dairy farm where I split my time between Vet Vision and the University of Nottingham. And we very simply moved animals from the old rubber mattresses that they were previously housed in to a newer, slightly wider barn with deep sand cubicles. And the animals in this building lie down an awful lot more. Now, what does this really equate to? Well, it was the same cows, the same farm, same feed, but they went up 3 litres per cow in milk yield overnight, which for this farm of about 300 cows equates to about 1,000 litres a day more production, purely because we've got more comfortable cows. So I guess there's a lot of different aspects to consider here. Currently, we've got lots of different technologies that are very, very good at monitoring bad things like lameness or mastitis, all of these bad things, and we can monitor those, identify them quickly, and hopefully treat them quickly. But we do need to stop them happening before they occur. What I suppose I'm really excited about is the potential of using AI and particularly computer vision in how we can monitor some of the more positive outcomes as well. And I think for the industry as a whole, this is a tremendously exciting possibility for us to monitor positive outcomes as well as the negatives. And if we can monitor some of those positives 24 hours a day, 365 days a year, we can start to change elements of those animals' environments that really facilitate those animals not only having a neutral life, but a good life. To that end, we are expanding our team through an investment round currently, but we're also recruiting additional computer vision developers, and particularly I thought of interest to this audience as well, a PhD opportunity as well, where we'll be disentangling some of the complexities between changes in animal behaviours and changing in some of their other parameters such as milk yield and so on as well. So thank you very much for your time and attention. I'd love any comments during the Q&A section, or if you'd like to get in touch directly, either through my Vet Vision hat or my University of Nottingham hat, would be very welcome. Thank you.
Thank you, Bobby. Great work, really great work. And I think the very fact you asked yourself that question about do you do your job to the best you can shows that you obviously do your job to the absolute best you can. So great work, and we're excited with the work that Vet Vision AI does. I'm conscious of time. I'm going to ask one question. In the absence of any questions coming in from the chat, can I ask the speakers to put their cameras on and turn their microphones on, please? Because I'm going to ask just one kind of broad question that I think a number of you sort of touched on, but I did just want to just kind of get a sense from you on that. So Zoe, yep, I think you're all here. So a number of you have talked about the wider supply chain, and Bobby, you referenced it also in your talk, and Francoise with the Waitrose relationship. What's the motivation for this from a commercial imperative? Because obviously in the UK we have welfare standards, and they're very high ones and they're very good ones. And in terms of international trade, it's something that we need to protect very, very carefully. But can I just ask each of you around the motivation from farmers' perspective? Will it be a carrot from their supply chain customers, or will it be a stick from the regulators? And how do you see that all getting embedded into the supply chain? Don't know if anyone's got any initial thoughts on that. Bobby?
Yeah, I'd love to. I'm sure everyone's got something to add on that. I don't think it can be a stick, as it were. I think that would be quite a negative way of going about this. The consumers of meat and dairy products nowadays are really savvy, aren't they? And they really care about animal welfare quite deeply. And I think unless we are able to demonstrate that it is positive animal welfare that we have within that supply chain, I think by definition that industry is not sustainable. The consumer won't accept that, and rightly so. I mean, it's brilliant being able to be held to that kind of account. But I think for the farmer as well, I think most farmers do deeply care about their welfare and really want the best for their animals, but they are also a business and they have to demonstrate that return on investment as well. But I don't think they're opposing factors. I think, you know, if we can demonstrate that positive animal welfare also has the benefit of they will produce more milk as well and be much more sustainable too, then I think that can only work wonders. So I think hopefully if we can demonstrate that they work in tandem rather than opposing, I think it's a benefit to everyone across the supply chain.
Great. I can see lots of nods on my screens. Anyone else with anything to add to that? Francoise?
Well, no, I agree with everything that Robert said, just maybe and I can't really speak for Waitrose, obviously, but I think in light, actually exactly today, a week ago, this new report came out on UK farm assurance, and there were really strong conclusions on the need to make farmers, you know, to have them participate in the setting and creation of animal welfare standards. And so I think to lift the whole thing into a positive endeavor is incredibly important, where and the work I did, the farmers, yeah, they were proud of their work and they were pleased that there was a formal system that allowed them to demonstrate that to the public and say, we are engaged in a process of care. You know, we are creating we have a culture of care, and we introducing these positive new indicators. You know, Zoe showed a whole range of them. I think that is a thing that needs to be communicated to the consumers as something the farmers are doing, and that's a very positive atmosphere.
Yeah, absolutely.
Right,
any other, Phil? Yeah.
So an advert on the TV a couple of days ago for Red Tractor, you know, promoting some of their newer standards, and I noticed that, you know, they were saying each animal has their own vet and their, you know, and a specific herd health plan. I still think we've got some way to go in turning the herd health plan from a tick box exercise, which is seen by a lot of farmers. You know, we get phone calls saying, my inspection is tomorrow, can you sign my herd health plan? And, you know, as a business, and part of my role as business development manager is trying to, you know, move towards a more proactive version of that. And I think all of those you know, the welfare measures and that kind of thing, if it can be quantified, can then start being brought into that to just to build on the trust and the value of it. But I think it's good to start seeing, you know, that type of thing being advertised to consumers.
Absolutely. And big ups to Esther for bringing her own companion animal to this welfare conversation.
The cat is here to remind us of the unknowability of animal lives, I assume. But in terms of speaking with stakeholders, one thing that's come through is obviously the technology doesn't negate the need for good stockmanship. And I guess there's an opportunity there in terms of working with farmers to see how these technologies can reduce labour and actually enhance their stockmanship. You know, you're still having to look at the animals that potentially your system flags as needing further investigation, but it might reduce the fact that you're having to do those really in-depth examinations of every single animal, and that you're using the technology to give you more time to look at those animals that the technology indicates to you requires that closer look, so that you can act before it becomes a problem. So it's more like it's an enhancement tool that can save you time rather than that the technology does the work of the stockman.
Yeah, absolutely. So would you like the last word? You gave us the first word. Would you like the last word?
I think we've covered a lot of it. Yeah, I agree. I think we should be looking for the opportunities to use technology to take away mundane tasks that you know, are time consuming but not necessarily critical to the animal. I think I'm still of the mind that at the moment, I think a lot of the commercializable technologies are those that provide that are working on that kind of like enhanced production, providing some kind of financial payback. So if you don't detect estrus, there is a financial penalty for that if you don't. So I think we've still got a little way to go and a bit of a change of mindset before we start thinking about, actually, can we create an animal-centered environment for them to live in? Our buildings and our infrastructure is based on the convenience of keeping it clean and tidy, the convenience of the stock person, and the machinery, and then the animal. We haven't flipped it on its head yet. We haven't gone, what does this animal need? How do we build a future-proof housing that copes with environmental challenges, heat challenges, all those sorts of things, and allows the stockman to work effectively? And I think we still need a change of mindset on that, and technologies will come into supporting that at the same time.
Brilliant. Excellent. Excellent. Right. I'm conscious that we've all been going for quite a while. Can I suggest that we have, it was going to be a 5-minute bio break. Can you come back at 12:25, please? Please go and charge your glasses, do whatever you need to do. And we'll have a clucking good conversation about poultry after the break. So thank you all so much, and see you in 5. Okay, can I start reminding you to come back into the call, please? And I'm going to ask Stuart to maybe put your camera on, and so we can give everybody maybe 30 seconds to do whatever they need to do.
Can you hear me right, Belinda?
Yeah, I can hear you fine, thank you.
Good.
Yeah. How are the hens this morning?
Yeah, they're tucked up nicely in the sheds today. Yes, pretty blustery here today, so yeah, they're quite safe and happy.
Yeah, best place to be, and some nice controlled environment. Yeah,
best place to be. Yeah.
Okay, right. So we've heard a lot this morning from people who've been talking about what is happening to things on farm and what farmers are doing. And we're now going to hear from someone who runs an actual farm business. So Stuart Laws from Uphouse Farms. Stuart, I don't think you've got any slides, have you? So we're going to hear proper from the heart about where you would like to see the technology going. So I'll shut up and I'll leave you to share your thoughts. Over to you.
Thanks, Belinda. Yeah, hi everyone. Yeah, I've been asked just to give a bit of an on-farm scenario about where we are with our journey. So a little bit of a background. So we are a family-run business started by Nigel and Jenny Joyce back in 1997. We rear poultry. Is our main enterprise of the farm, and we've been doing that since 1997 as a business. We're currently rearing at any one time around 750,000 birds, and yeah, very excited to see where the future is going at the minute. Where we've historically been in the current situation we are in is that we've spent a lot of time. I mean, I joined the business 6 months ago, and I joined to a plethora of data. Data collection has been a focus of production here ever since it started. I mean, I've got data available to me since the very first flock that was brought onto farm, and we record, daily records of things: temperature, humidity, CO2, ammonia in the sheds, feeding patterns, water consumption. Every facet of the environment that we're providing for these birds is monitored on a regular basis. Alongside that, obviously, we have the stockman, and which is integral, and we have 7 full-time stockmen that look after all the birds here. And we're very much relying on them and their skill sets, which is paramount to how we perform, which has been very successful over the years. What we are hoping to achieve, it became very apparent to me that there's a lot of technologies out there that could add layers to our stockmanship across the farm, and that's very much our focus. The small details that in how we manage and optimize the environment for the birds can have really large effects and have really big benefits to both birds, the staff, and obviously the business. So that correlation really resonated with me quite early on, and how we can really generate some really real-time data to really add layers to our stockmanship. And obviously the advent of obviously trying to implement some of these technologies can really add a 24/7 stockmanship control measures to our sheds, and trying to do that without adding excess levels of stress to the birds. Every time we enter the sheds, that changes the dynamic in the sheds, which we obviously wanted to try and monitor these situations without obviously changing that dynamic by being present. So and there's some really innovative ideas coming forward, and it's something where we are at the minute is in terms of how we gain further insights and monitor the environment for the birds. We're quite passionate about trialing and trying new ideas, and that's very much derived from the team. They're passionate about what they do, and they really want to generate the best performance and quality and welfare for the birds. So they're really much trying to change things on how they, control the environment for the birds. And, my role in this is trying to give them the right tools to really deliver what their own passions dictate, really. So, being able to apply that 24/7, stockmanship within the sheds is a real focus for us and our ambition to what we want to do going forward. Being able to sort of continually monitor these birds as we move forward, and as we try new ideas, to actually monitor the subtle differences that make such a big impact, really is, a real game changer for us. There's a lot of correlation between what we've heard already, in terms of automation. A lot of our processes at the minute are very manual based. Our data collection is quite manual. We have systems that monitor the sheds, which automatically control the sheds, but then the data collection for that is quite automated. So there's a process there of trying to automate that process of data collection, and then ultimately be able to use that to benefit the birds. And trying to monitor all our KPIs, as we move throughout in a real-time basis. Our approach at the minute is that we sit down on a daily basis, and record our data on a daily basis in the mornings. Then that's done on a, so we record this morning's data was, this morning's data collection was for the 24 hours previous. So what we really want to move towards is a continual real-time approach to this, and again adding more layers to what we can do ourselves, and what we can do with the stockmanship we have on farm already. So we've been exploring, and that's really where we are at the minute. So we're very much at a point of exploration of new technologies, and how that and a lot of that's come from our connections with the Agri TechE team, and some different people who've brought some really clever ideas to us in terms of how we monitor, feed and water consumption, how we can monitor behavior monitoring with some of the camera technology. We've heard about some of that already. I saw Angela was on the call. We had a very interesting conversation with Angela from RoboScientific about monitoring early disease, detection in birds, which is quite exciting. And and also there's some pretty interesting technology around monitoring acoustics in the sheds as well, which I know has been applied in other livestock. So we're very much at that point at the minute where we've been out there and we've seen all these various lovely ideas, and then we're trying to bring it back and trying to apply it on farm, which is very much being where the challenges start to come. We're a well-established business, and trying to embed some of these various data centers into our existing platforms is some of the challenge. We trying to provide the foundations to be able to apply some of these technologies, which it goes without saying that there's some really exciting stuff out there, but how we actually bring it all together into one hub, so to speak, on farm, which then meets the ambitions that we've set out. That's quite a big challenge actually, and one that we're having to really dive deep onto to try and get the right solution to that. Is that how we can provide the centralized hub of information that we can then provide to the stockman. Future proofing, if anything, the process of where we are at the minute has proven that we don't know what's around the corner, and making sure we get the foundations right, as I mentioned already, about how we can get the right layers at the base of this pyramid to really allow us to exploit some of the potential opportunities that are going to come in the future as well. So, and I think that's where, again, one of the big challenges lie. We've got a lot, and how we can use the data we're already collecting. We're gathering a lot of data. If we can automate that, provide more time for the staff to really focus on the birds, that's a great move. But then equally so, how do we actually utilize that data that we're already providing, they're already gathering, and really deliver some of our objectives. So, yeah, that's the point we're at. Is at the minute there's lots of ideas, lots of innovative solutions out there. For us, the main challenge is how we now apply them on farm in an established business, to really generate some really good results and positive results for the birds moving forward, really. So yeah, that's pretty much a whistle-stop tour through where we are on our journey, and yeah, it's pretty much it's on farm. It's pretty practical based, and you know, and I'm really excited. And I mean, working with Belinda and the rest of the team at Agri Tech has been quite a game changer for me over the last 6 months, and learning what opportunities are out there. And you know, I'm actually quite excited for the challenge of really trying to apply that on farm now.
Stuart, you are a star. That's inspirational stuff, and would that every farmer the world over that manages animals and birds and fish had your mindset and your attitude. And just say we stand alongside you in awe, because you know, you have a lot of challenges. We talk a lot about AI in the artificial intelligence context. You have another AI that is currently looking over your shoulder with avian influenza, and you do an amazing job. So
one of the other points is time, isn't it? You know, one of the other challenges we face, and I face here, is time. You know, a lot of these projects that we're looking at the minute, you know, we don't want to detract ourselves from the day job. You know, our primary focus is looking after the birds, and we're giving ourselves the amount of time we need to really fully analyze and implement these processes. It is something that I hadn't fully appreciated until recently, really. So yeah. So yeah. And
right, thank you for sharing that. And yeah, maybe if you could turn your camera and mic off, and we'll see you a little bit later on, while I introduce Angie Curtis from RoboScientific. Now, RoboScientific technology, we've put this in a poultry session, but Angie, you're pretty much across all livestock, but we've put you in the poultry session for quite a specific reason. But Angie, goodness me, RoboScientific's technology, tell us all about it.
Hi, Belinda, thanks for that. And I hope you can see my window. I can't see it.
We can't actually, Angie, at the moment.
It said it was there. Hang on. Window. There it is. Oh, hang on. Sorry. It's always me. I am so useless at technology. There we go. Can you see it now? No.
I'm afraid not quite yet.
Okay, let me start again. Let me just
to reassure everybody that the technology on farm is 100% better than the technology
on
a webinar.
Yeah, I don't do the technology, I have to say. I just do the talking. But yeah, it's there. It's there.
Christina, can you help?
If you press share your screen and choose the window, not the screen, or not in the screen section, but in the window section, your PowerPoint presentation.
That's exactly what I did. I've gone to window, and then
Christina, can we run a parallel version?
Let me share my screen, and yeah, I can do.
Good idea. Hooray. Right. Okay, super. So it's on there now, yeah? Fantastic. Thank you very much. Yeah. And as they said, I don't do the technology, I do the talking. But anyway, thanks to Phil and to Stuart, first of all, for giving us such a lovely plug. As Phil mentioned, we're actually up in Cheshire this week installing breath monitors for calves. But today I'd like to tell you about our poultry system, which uses a monitor in the same way as a smoke alarm works. So it samples the air in chicken sheds to raise an alarm when a disease event occurs. Next slide, please, Christina. We've developed a new type of sensor which detects disease outbreaks automatically in real time. This enables the farmers to perform early interventions which could reduce weight loss and deaths due to disease and improve biosecurity. Our aim is to increase the number of diseases detected, even to include avian flu within 2 years. Currently, we can detect coccidiosis, Clostridium perfringens, Campylobacter, necrotic enteritis, and gangrenous dermatitis. And to give you an idea, what we need to do when we're detecting a new disease is identify what the VOCs are that are associated with it, which is fairly straightforward. create a prototype sensor array, and then try it out and see if it works. And then all we have to do is just confirm the algorithm for the pass-fail and let artificial intelligence do its wonderful work. But we believe our early disease detection system, the Farm Protect Monitor, will provide a reliable and consistent monitor of the bird's disease status, even when there's no experienced stockman on site. Because the conversation I had with Stuart and his colleague Nigel recently was saying that the problem is ensuring that you always have an experienced stockman who knows what they're looking for. And we hope we can plug a gap there. And in this way, we can protect profits by detecting diseases such as coccidiosis and clostridiosis, as I mentioned, quicker, reducing the risk of necrotic enteritis, reducing mortality, and also obviously improving the quality of the birds that are produced. Next slide, please, Katrina. Our sensor platform uses VOCs, that's volatile organic compounds. These are the chemicals in smells, and they're our biomarkers. We've been developing the technology for over 10 years now, and I have to admit it does sometimes feel like a lot longer. And we'll be starting on-farm trials of the poultry monitor in about Q2 of this year. The monitor samples the air in a chicken house and extracts the VOCs to identify when there's an outbreak of disease or if there's another change in the status of the flock. Broilers are our first poultry target, and we're looking to add laying hens once the monitor's been adapted to match the diseases and the farming methods in that sector. As I mentioned, we're already working with dairy cattle, especially calves, detecting automatically from individual calves' breath while they're feeding from the robotic milk feeder. And that means we can actually sample the breath, analyze it, and get a result within 2 minutes, because we have 6 minutes typically when the calf is at the feeder. And we ally each of the results to the ear tag, which means that it enables the farmer to know pretty quickly if there's a problem with one of the calves. We're actually looking at bovine respiratory disease there at the moment. We've also proven our ability to detect diseases such as botrytis and mold in growing salad crops and soft fruits, including berries. I was delighted to identify a berry I'd tasted on farm in Waitrose this year, and in pickstone fruits and apples, as well as fusarium in grain. And we've also obviously completed the inevitable human health trials with COVID, where we were able to prove our ability to detect COVID from the air in a room containing an infected person, from samples of their taken from their clothes, and from their breath. And in fact, we were spectacularly successful in that. Thank goodness. Next slide, please, Katrina. Right. So volatile organic compounds, as I mentioned, they're the chemical compounds contained in an odour. So basically, our technology is working like a dog's nose. We sniff just to see what's present and what's happening. Their odours, the smells, are created by living organisms, animals or plants, and they're emitted into the atmosphere inevitably via breath, sweat, feces, and the other inevitable emissions that emanate from living organisms. And this means that VOCs are transient, and that means they provide a contemporary result in real time rather than recording what's occurred in the past. And you'll see that actually the problem with PCR, for example, is it can relate dead DNA or wait until the live DNA has created a sufficient volume to be identifiable. And then you have to do the timely sensing analysis. Our sensors are groundbreaking in their stability, sensitivity and specificity. Dogs' noses are the star performers in VOCs, obviously. They can typically detect the presence of VOCs at 16 parts per trillion. Now, we can achieve so far typically 10 parts per billion, which actually is, if you imagine less than a teaspoonful of in an Olympic-sized swimming pool. That's where we are in terms of our capacity. And some of our sensors are already at parts per trillion. And as artificial intelligence increases our knowledge base, then the performance will continue to improve, so that eventually, as Stuart was saying, in his ideal world, the system could provide a predictive model enabling even more effective management of flocks. With poultry and pigs, because of the size and the indoor farming environments, we test the flock or the herd. Whilst with the larger livestock like cattle, individual breath collection, especially when allied to ear tag identification, is a much more viable approach. Next slide, please, Katrina. Right, so here we have a VOC signature. This is what our sensors output. The image in the corner is the farm monitor. It's just a metal box that hangs in the space in a farm shed, in a chicken shed, and the outputs on the right in the graphs are the digital patterns they produce. Our sensor arrays contain 24 individual sensors, each tuned to a particular VOC. We automatically sample the air in a chicken shed for a typical 50,000 bird shed. That will take about 30 minutes. And then we extract the VOCs, analyze the individual sensor responses to see what the responses are and what patterns they make. So if you look again at those graphs, you'll see each individual line within the graph is an individual sensor within the array. And the flat line on the right of the screen is actually when it's returning to the base, so that after the response has been identified. And so if there is a significant change or a disease is spotted, an automatic alert can be transmitted via Wi-Fi or SMS to the farmer immediately so that he can decide what further action is appropriate. And I think that goes to points made earlier about the stockman will always have a role, because he will always be the one who knows what needs to be done. We will anonymize and collect all data from all units to build our knowledge using artificial intelligence. And then once, as the monitors grow in number, then we'll just continuously improve the performance of the monitors. No, that was great, Katrina. You can go to that one now. Thank you. You anticipated me. We're working currently with APHA, the Animal Plant and Health Agency, with trials at their Woking base. We're using trials currently to detect Newcastle disease, which is work they're working on now. They're enabling us to piggyback on other trials they're using, because they have great hope for how our disease detection will help control the transmission of diseases in the future. So if you look at the graph on the right of the screen, that will give you an indication of what we're seeing and how it works. The left-hand green ellipse is actually the identification of all of the uninfected chickens in this particular trial, which took place at Hanover University. And they were using a challenge trial where they had a group of clean chickens, if you like, uninfected chickens, and a group of chickens that were gradually infected, in this case with Campylobacter over time. And then the right ellipse on the right-hand side of the graph with the solid line, those are the confirmed infected diseases, which we too identified alongside the PCR check. And the PCR check was done alongside post-mortem. And then in addition to that, you'll see there's a dotted line, which is slightly larger surrounding the red ellipse. And that is our birds that we identified as being infected with disease ahead of PCR and ahead of any other indication, because we were, as I mentioned before, looking for symptoms of the disease as they were emitted into the air from the birds in real time. So on farm, the joy of our system is once it's on farm, our Farm Protect monitor is installed. It sits in the shed, quietly sampling the air. The monitoring is automatic and there's no further input costs. As I said, it's obviously down to the stockman or their vet what further treatments are required. Right, next and final slide, please, Katrina. So this is where we are at the moment. We don't have a production model as yet. We are at TRL 6, which is prototype ready for real world testing. As I mentioned, our development has taken place over the last 10 years. And during that time, we've worked with Nottingham University, Harper Adams and SRUC, all wonderful colleagues who have been here today, which is a joy. Farmers we've worked with over the past 10 years as part of our UK projects also include farmers that you might recognise: the Applied Group, Cranswick, Cargill, and Banham's Poultry. So the plan at the moment is we're doing the trials from Q2 of this year. We're doing them in the UK and in America because the farming systems are different, but we've identified that the diseases smell exactly the same. And we've been able to tune out things like ammonia. And once it's in production and it's working on farm, the vision is that sampling can occur as frequently as the farmer needs, hourly, 4 hourly, or whatever. But in conversation with poultry farmers, the general feeling seems to be, as Stuart explained, that if they can start the day, so for example, if we can sample the air at 5 o'clock for 30 minutes, by 5:32 the sample will have been analysed and a result transmitted to the farmer. So when work starts at 7 AM, they will know if there has been a disease outbreak in that shed overnight, and they can make whatever decisions need to be made for the day. And I don't need to tell you that when we get to avian flu, which we're fairly confident will happen this year, then that will be quite a godsend. And that's about it from me, I think. I'm happy to answer any questions you might have on chat. I think I can actually manage that technology. And anybody that wants to then just give me a shout.
Angie, thank you so much. And I think we all want to need your technology in all areas of not just farm life, but other life as well. So thank you so much for sharing that. Now, can I ask, is Thomas Stringer on the meeting? Thomas, we can't see you, or have you sent a substitute? We're fretting a tiny bit over here that we don't have our final speaker. So final call for Thomas Stringer from Flybox, or any associates from Flybox? If not, I will ask Angie and Stuart to come back on camera. One last call. Flybox, do we have you? No? Okay. Angie, would you like to come back? Because we've got about another sort of 8 minutes or so. And I have a question for both of you, sort of being kind of two sides of the same coin, is what do you want to see from each other? So Stuart, maybe if we could start with you, what do you want to see from technologists that are beating a path to your door saying, we've got this whiz bang new solution? What's your ask to them when they approach you for that conversation? And then to Angie, what do you want to see from the farmers who you're approaching? So what's your ask to each other? Not specifically each other, but to any technologist, Stuart.
Well,
what would you
this
say?
It's really interesting because Angela and I, we had a good session discussing the very subject of what she's discussed today about a couple of weeks ago. So, I mean, Angela's product that she's offering is very much aligned with what every stockman wants, is to be able to look after their birds, and in our setting, look after birds, and be able to do that and be ahead of the curve, and be, very much a lot of the stockmanship that we've done, and as I mentioned before, the data collection has always been retrospective. So you're always waiting for the event to happen before you can actually collect the data or analyze it. What Angela is offering, which is this is pinpoint to what we want to achieve, is the ability to be able to be prepared for, and manage the scenario preceding the event getting to a critical point. The point we are at the minute is where stockmanship only responds to when the birds have a challenge or an issue, and at that point you're always fighting against the challenge. Whereas if you can get ahead 2 or 3 days ahead, and then you can probably manage the environment in a different way. If you can then manage the environment, you can then potentially avoid the use of antibiotics or any other products. There are other methods you can apply at an early stage that you can't apply once the challenge gets to an advanced level. So that's a real focus of ours, is to really be ahead of the curve, really. And obviously monitoring behaviors in the shed is something else that, because as I mentioned before, whenever you enter a shed, it changes the whole dynamic. The birds know you're there, and they see you there, they know you're there. And as much as we can use our own instincts and own senses to analyze what's in the shed, there's nothing better than being able to monitor the birds when you're not actually in the shed, so they don't know you're there. You know, I did this in very early on in my career in a lambing setting where I could monitor sheep in a lambing shed, and you could, you know, and I really want to try and apply that, you know, in this setting really. So there are two real points for me.
And is it important that the technologist can help you calculate return on investment, or will you do that? You don't need someone to talk to you about the finances, or do you?
No, I think that's my role in that personally.
Yep.
I think that's really my role, and we've explored various different technologies, and we've applied that very mindset, and we've evaluated them on their merits. And you know, and I mentioned before, there's a lot of different technologies out there, and we're going to have to prioritize where we're going to go with this, because there's so many out there actually when you actually open the Pandora's box on this.
Yeah.
And we're going to have to prioritize, and it's going to have to be driven by return, you know, and which ones meet our objectives, you know, more readily than what alternatives are.
Sure.
So yeah, that's very much our role in this, and I think some of that is applying our own individual settings, because everyone has their own objectives, everyone has their own individual setting, and their own objectives to how what they want to achieve. So
yeah,
I think that's very much our role in this.
Brilliant. And Angie, what makes the perfect farmer to approach to adopt your technology?
I'm here.
I was just thinking, don't tell them about the cash yet, Stuart. It's fine. No, we actually, the kind of conversation I had with Stuart is exactly recently is exactly what we need, because as with any manufacturer, you come up with a vision and you have an idea and you've got the solution for the world. And then you go and you talk to the world and you find that actually the world doesn't need your vision. The world needs just a better fish and chip shop or whatever it may be. So talking to Stuart, it was quite reassuring. I don't know if you'd agree with this, Stuart, that we did seem to be aligned on most of our assumptions and your needs. There were some I think he corrected me on, and I'm gone away to reevaluate it. But that's the most important thing for us at our stage of development at the moment, right across agriculture, is farmers giving us access to understand what their needs really are and what the economic cost benefit to them of our solution is. Because again, if we were to come up with our system and it was going to come out at 100,000 a unit, I think every farmer in the country would be bursting his sides with laughter, because it clearly wouldn't make sense. So we've actually managed to tailor it to a point where it is very affordable. We're talking at sort of sub £10,000 a shed, and so it makes it manageable.
Brilliant.
So that's the big thing. It's the conversations and the feedback is what we need at the moment.
Brilliant. Well, it sounds like a match made in heaven, and we will await developments eagerly. But for now, thank you both so much for being part of our event today. It's been a pleasure to see you and to hear from you. So thank you. We really appreciate you giving up your time this morning. And with that, to everybody else on the call, thank you very much for being with us. I think we've had a great retention rate for this event, as well as still so many of you on the call, which is fantastic. If I can just flag up, we've got a number of events coming up, including Connections Week, which will be the 3rd to the 7th of March. There's a lot of activity going on that week to help you broker the kinds of connections you've just heard about between Angie and Stuart. If you're a researcher, a farmer, tech developer, Connections Week is for you. And also, if you don't already receive our newsletter and indeed our member mail, please do sign up to do that. There was one landed last week. So if you didn't have one last week, you're not signed up to it. So please head over to the link that Christina's put in the chat and be part of the community.